What is beyond the edge of the universe? Take a moment and imagine the fastest journey ever conceived. Not by airplane, not by rocket, not even by the speed of light. Imagine that, somehow, every law of physics steps aside and allows you to travel endlessly through the cosmos. You leave Earth behind. Within seconds, the moon becomes nothing more than a bright stone floating in darkness. Minutes later, the sun shrinks into another ordinary star. The planets disappear one by one, until the solar system itself becomes impossible to distinguish from the billions of other planetary systems scattered across the Milky Way. You continue forward. The spiral arms of our galaxy slowly unfold beneath you, like glowing rivers made of hundreds of billions of stars. Eventually, even the Milky Way becomes just another point of light. Ahead lies the vast collection of neighboring galaxies, known as the local group. You pass Andromeda, then Triangulum. Soon thousands of galaxies surround you. Then millions, then billions. Space itself seems endless. For billions of years, you continue your impossible journey, crossing distances so enormous that numbers begin to lose their meaning. Every direction reveals more galaxies, more stars, more darkness, and eventually, one question begins to dominate every thought. Where does it all end? Does the universe have an edge? If it does, what lies beyond it? Is there an enormous wall surrounding everything that exists? An infinite empty void? Another universe waiting outside our own? Or is the question itself based on a misunderstanding of reality? For thousands of years, humanity has searched for the answer. Ancient civilization imagined enormous domes covering the sky. Some believed the stars were holes through which divine light shone. Others imagined endless oceans surrounding the heavens. As our knowledge grew, those ideas disappeared one after another. The Earth was not the center of everything. The sun was only one ordinary star. Our galaxy was only one among hundreds of billions. Each discovery made the universe larger. Each answer created even greater mysteries. Today, thanks to powerful telescopes orbiting above Earth's atmosphere and observatories spread across our planet, scientists have mapped farther into space than anyone once believed possible. Yet despite all of our technology, despite centuries of observation, one astonishing fact remains. We have never seen the edge of the universe. Not because our telescopes are too weak, not because we have not looked hard enough, but because reality itself refuses to let us see farther. To understand why, we first have to answer a surprisingly simple question. What exactly is the universe? Most people imagine the universe as a gigantic empty box. Inside that box are galaxies, stars, planets, nebulae, black holes. Everything exists somewhere inside an enormous container called space. It sounds reasonable. It is also wrong. Modern physics tells us that space is not a container holding the universe. Space is part of the universe itself. There is no giant room outside it, no cosmic warehouse containing galaxies. Space, time, matter, and energy together form the fabric of reality. If space itself is expanding, asking what lies beyond the universe may be like asking what is north of the North Pole. The question feels natural, yet the answer may not exist in the way we expect. This idea is difficult because our brains evolved to understand everyday experiences. Every room has walls. Every ocean has a shore. Every road eventually reaches another place. Our intuition insists that everything must have a boundary, but the cosmos has never cared about human intuition. Again and again, the universe has revealed that reality is stranger than imagination. The Earth feels flat beneath our feet, yet it is round. The sun appears to move across the sky, yet it is the Earth that rotates. Solid objects feel permanent, yet every atom inside them is almost entirely empty space. If our instincts can mislead us on Earth, imagine how unreliable they become across billions of light years. To understand the edge of the universe, we must begin at the beginning. Nearly 13.8 billion years ago, the observable universe was unimaginably hot and dense. Contrary to a common misconception, the Big Bang was not an explosion into empty space. There was no pre-existing void waiting to be filled. Instead, space itself began expanding everywhere at once. Every location we observe today was once compressed into an extraordinarily dense state. As expansion continued, temperatures fell. Within minutes, the first atomic nuclei formed. Hundreds of thousands of years later, electrons combined with those nuclei to create the first neutral atoms. For the first time, light could travel freely across space. That ancient light is still traveling today. It fills every direction of the sky as a faint microwave glow known as the cosmic microwave background. It is the oldest light we can ever hope to observe. Beyond that point, the universe was opaque. Light could not travel freely. No telescope, no matter how powerful, can directly see earlier than this using ordinary light. Already we encounter our first horizon, not an edge, a limit imposed by physics itself. As millions of years passed, gravity slowly gathered enormous clouds of hydrogen. The first stars ignited. Inside their blazing cores, simple elements fused into heavier ones. Carbon, oxygen, iron. The atoms that now make up our bodies were forged inside stars that died billions of years before Earth even existed. In a very literal sense, every human being is made from ancient stardust. Galaxies formed, clusters emerged, immense filaments stretched across unimaginable distances, creating a vast cosmic web. From far enough away, the largest structures in the universe resemble glowing threads connected across oceans of darkness. Our own Milky Way occupies only one tiny location within this enormous network. Yet even this description hides an astonishing truth. Everything we have ever observed, all the stars visible in the night sky, every galaxy photographed by the Hubble and James Webb Space Telescopes, every black hole, every planet, every cloud of gas represents only the observable universe. And that distinction changes everything. The phrase observable universe is one of the most important ideas in modern cosmology, yet it is also one of the most misunderstood. Many people hear it and assume it simply means we have not built telescopes powerful enough. That is not the case. Even if humanity constructed a telescope the size of an entire galaxy, it would still encounter the same fundamental limit. The boundary is not created by our technology, it is created by time. Light, despite its incredible speed of nearly 300,000 kilometers every second, is not instantaneous. Everything we see is a message from the past. When you look at the moon, you are seeing it as it was about 1.25 seconds ago. The sun appears as it existed more than 8 minutes ago. The nearest star beyond our solar system is seen more than 4 years in the past. The Andromeda galaxy appears as it was roughly 2.5 million years ago, long before modern humans existed. Looking deeper into space is not simply looking farther away. It is looking farther back in time. The farther we observe, the younger the universe becomes. This turns every telescope into a time machine. Not one that moves us into the past, but one that allows the past to reach us. Every photon crossing the darkness of space carries a story. Some began their journey before Earth formed. Others left their galaxies before our sun was born. Many have traveled for more than 13 billion years before finally ending their journey inside a detector built by intelligent beings on a small blue planet. That realization is extraordinary. Some of the light captured by modern telescopes has spent almost the entire age of the universe traveling through space. And yet there is a limit. No matter where we point our instruments, there comes a distance beyond which no light has had enough time to reach us. Imagine standing in the middle of a dense forest at night, holding a lantern. You can only see as far as your light reaches. Beyond that distance, the forest still exists. You simply cannot observe it. The observable universe works in a similar way. Its boundary is not necessarily the end of reality. It is the end of what information has been able to deliver since the beginning of cosmic time. Today, astronomers estimate that the observable universe stretches approximately 46 billion light-years in every direction. At first, that number seems impossible. If the universe is about 13.8 billion years old, shouldn't the limit be 13.8 billion light-years? The answer reveals another surprising feature of reality. Space has not remained still. While light traveled toward us, the fabric of space itself continued expanding. Imagine drawing 2 dots on the surface of a balloon. As the balloon inflates, the dots move farther apart. even though neither dot is crawling across the rubber. The surface itself stretches. The universe behaves in much the same way. Galaxies are not generally flying through space away from one another, like fragments from an explosion. Instead, the space between them expands. This means the place where a distant galaxy emitted its light billions of years ago is no longer where that galaxy exists today. By the time its ancient light reaches us, the galaxy may have been carried tens of billions of light years farther away. The universe is stranger than almost anything our intuition suggests. Even more astonishing is the fact that some galaxies are now receding from us faster than the speed of light. At first glance, that sounds impossible. After all, Einstein taught us that nothing can travel faster than light. The key word is travel. Nothing can move through space faster than light. But space itself is under no such restriction. If the fabric of the universe stretches quickly enough, two distant galaxies can separate faster than light without violating the laws of physics. This subtle distinction changes everything. It means there are galaxies whose present light will never reach Earth, not because they disappear, not because they stop shining, but because the expanding universe continually creates more space between us and them than their light can ever overcome. Every second, portions of the cosmos quietly slip beyond our reach forever. In a very real sense, the observable universe is shrinking in terms of the information we will one day be able to receive. Future civilization, billions of years from now, may see a dramatically emptier sky. Many distant galaxies visible today will have vanished from view forever. Their light will never arrive. Evidence of the Big Bang itself may become impossible to detect. Those future astronomers might conclude they inhabit a lonely island galaxy, surrounded by infinite darkness. They could completely miss the true history of the cosmos simply because time erased the evidence. We are fortunate to exist during a remarkable era, an era when enough light has reached us to reconstruct much of cosmic history. Yet even now, enormous mysteries remain. One of the greatest concerns, something that dominates the universe, but cannot be seen directly: dark matter. When astronomers measured how quickly galaxies rotate, they found something impossible. The visible stars did not provide enough gravity to hold galaxies together. According to Newton's laws, galaxies should have flown apart long ago. Instead, they remained intact. Something unseen was supplying additional gravity, something massive, something invisible. Today, scientists estimate that ordinary matter, the atoms making up stars, planets, oceans, trees, and people, accounts for only about 5% of the universe. Roughly 27% appears to be dark matter. It neither shines nor absorbs light in any familiar way. Its presence is revealed only through gravity. Without dark matter, galaxies like our own might never have formed. The Milky Way, the solar system, Earth, and perhaps life itself owe their existence to something we still do not fully understand. Then comes an even greater mystery: dark energy. In the late 20th century, astronomers expected gravity to slow the expansion of the universe over time. Instead, observations revealed something astonishing. Expansion is accelerating. The farther galaxies are from one another, the faster space expands between them. Some unknown phenomenon appears to be pushing the universe apart. Scientists call it dark energy, not because it is dark in color, but because its true nature remains unknown. Current observation suggests that dark energy makes up nearly 68% of the entire universe. Think about that for a moment. Everything humanity has ever touched, built, studied, or dreamed about represents only a tiny fraction of reality. 95% of the cosmos consists of phenomena we still struggle to explain. The greatest scientific revolution of the future may not involve discovering something entirely new. It may simply involve understanding what has surrounded us all along. This realization changes the original question. When we ask what lies beyond the edge of the universe, we assume we already understand what the universe is. But perhaps we do not. Perhaps we have mapped only the smallest visible layer of a far deeper reality. History has repeatedly shown that every time science believed it had reached the limits of knowledge, another horizon appeared. The Earth was not the center. The solar system was not unique. The Milky Way was not alone. Visible matter was not the whole universe. Each discovery made reality larger than before. There is every reason to believe the next discovery will do the same. If the observable universe is only the portion we can see, then an unavoidable question follows. How large is the entire universe? The honest answer is remarkably simple. We do not know. This is one of the few scientific questions where we don't know is not a failure. It is the most accurate answer possible. Everything beyond the observable universe is hidden from us by the finite speed of light and the age of the cosmos. No spacecraft can reach it. No telescope can photograph it. No signal has ever crossed that unimaginable distance to tell us what exists there. Yet scientists are not left completely in the dark. Physics allows us to make educated inferences. Imagine standing in the middle of the Pacific Ocean. The horizon surrounds you in every direction. From where you stand, the ocean appears to end at that distant line. But you already know the horizon is not the edge of Earth. It is merely the limit of what you can currently see. As you travel forward, the horizon moves with you. The same principle may apply to the universe. Our observable universe could simply be our cosmic horizon. Beyond it, space may continue for unimaginable distances. If this picture is correct, then somewhere far beyond the most distant galaxy we can observe, there are countless other galaxies, other galaxy clusters, other cosmic webs stretching across the darkness. Perhaps there are stars whose light will never reach Earth. Perhaps there are planets older than our own. Perhaps entire civilizations have risen and disappeared without leaving even the smallest trace that could ever reach us. This possibility is not science fiction. It naturally follows from the mathematics describing cosmic expansion. If the universe is indeed much larger than what we observe, then the number of galaxies beyond our horizon could exceed the number within it by an incomprehensible amount. Some cosmologists even suspect that the entire universe may be infinite. Infinity is an unsettling concept. Human intuition resists it. Everything in everyday life has limits. Every building has walls. Every road ends somewhere. Every lifetime has a beginning and an end. An infinite universe would be different. No center, no outer boundary, no final destination. You could travel forever without ever reaching an edge. That sounds impossible. Yet modern mathematics has no problem describing such a reality. An infinite universe would not require an edge, because edges only exist when something ends. Infinity never ends. To visualize this, think about the surface of Earth. If you begin walking in one direction and never stop, you will eventually return to your starting point. At no point do you encounter the edge of the planet. The surface is finite but unbounded. Now imagine adding another dimension. Some physicists have suggested that our universe could possess a similar geometry on scales so enormous that we cannot yet detect its curvature. If that were true, traveling in one direction for an unimaginable length of time might eventually bring you back to where you start, not because the universe has walls, but because space itself curves. Current observations suggest that the observable universe is astonishingly flat. Measurements of the cosmic microwave background indicate that if any curvature exists, it is incredibly small. From everything we can measure, space appears almost perfectly flat across billions of light years. Whether it remains flat forever is one of cosmology's greatest unanswered questions. Then there is another possibility. Perhaps asking what lies outside the universe is like asking what is outside all directions. The question may contain an assumption that reality does not satisfy. When we ask what lies outside a house, we imagine stepping into a larger space. But if space itself is the thing we are talking about, there may be no larger arena waiting beyond it. There is no requirement that the universe be embedded inside another physical space. According to Einstein's general theory of relativity, space and time are not passive backgrounds. They are dynamic parts of reality. Gravity is not an invisible force pulling objects through empty space. Instead, massive objects curve spacetime itself. Planets orbit stars because they follow the geometry of curved spacetime. Galaxies move within an evolving cosmic fabric. If spacetime is the stage, then asking what lies beyond it becomes extremely difficult. Beyond where? Beyond what? There may be no meaningful direction in which outside exists, yet physics does not stop there. Some of the boldest ideas in modern cosmology suggest that our universe may be only one region within something far larger. This is where we must be careful. Unlike the Big Bang or cosmic expansion, these ideas have not been confirmed. They remain hypotheses, mathematical possibilities, supported by some theoretical models, but not directly observed. One such idea is the multiverse. The word has become popular in movies and television, but its scientific meaning is far more subtle. Certain versions of cosmic inflation, the extremely rapid expansion believed to have occurred fractions of a second after the Big Bang, suggest that inflation may not have ended everywhere at the same time. Instead, isolated regions could have stopped inflating and formed universes like ours, while other regions continued expanding. If this picture is correct, our observable universe could be one bubble in a vast cosmic foam. Each bubble would possess its own spacetime. Some might contain galaxies, others might remain empty. Some could have physical constants different from ours. In others, stars might never form, or chemistry itself might be impossible. At present, there is no direct observational evidence that these other universes exist. Scientists debate whether they can ever be tested. For that reason, the multiverse remains an intriguing possibility rather than an established fact. Another fascinating idea comes from quantum mechanics. Some interpretations suggest that every quantum event branches into multiple outcomes. According to this interpretation, reality continually divides into countless parallel histories. Again, this is not proven. It is one interpretation among several competing explanations of quantum physics. What all of these ideas share is a reminder that the universe may be far stranger than our everyday experience allows us to imagine. Every century has expanded humanity's view of reality. The next century may do the same. Perhaps future generations will look back on our understanding of the cosmos the way we now look back on medieval maps of the world, remarkable for their time, yet incomplete. And that possibility should not discourage us. It should inspire us, because every unanswered question is also an invitation to explore. Every mystery marks the beginning of another journey. Every horizon exists not to stop us, but to challenge our curiosity. When we first asked whether Earth was flat, the answer changed civilization. When we asked whether the sun or Earth occupied the center, the answer transformed science. Now we ask what lies beyond the edge of the universe. Perhaps the answer will once again reshape everything we believe about reality. Or perhaps the greatest discovery will be realizing that there never was an edge at all. As we continue to push the boundaries of observation, we are also peering into the future of the universe itself. Because the edge of the universe is not just a question of space, it is also a question of time. Right now, galaxies are moving apart at an accelerating rate. Dark energy is stretching the fabric of space faster and faster. And if this continues, the future of the cosmos will look nothing like its present state. In about 100 billion years, the Milky Way will no longer see most of the galaxies we observe today. They will have drifted beyond the cosmic horizon. Their light will never reach any future observers. The night sky will become darker, not because the stars go out, but because the universe itself carries them away from view. Eventually, only gravitationally bound systems will remain visible. Galaxies like ours may merge into a single giant structure. Beyond that, even those remnants will fade. As stars slowly burn out over trillions of years, new stars will stop forming. The universe will gradually enter a long, silent phase often called the heat death, a state where energy is evenly distributed and no usable work can be extracted. No engines, no stars, no chemical processes capable of supporting life as we know it, just an expanding darkness filled with fading remnants of light. In that distant future, intelligent observers, if they still exist, may look up and see almost nothing beyond their own galaxy. They would have no idea that billions of other galaxies once filled the sky. Just as we cannot see beyond our observable horizon today, they would be trapped within their own shrinking cosmic bubble. This raises a disturbing thought. We are not only limited in space, we are also limited in time. There is a cosmic window in which the universe is understandable. Too early, and nothing exists yet. Too late, and everything has already disappeared beyond reach. We exist in a rare moment where the universe is still readable, where light from distant galaxies has not yet vanished forever, where the story of cosmic evolution can still be reconstructed. This may not be accidental, or it may simply be luck, but either way, it means something profound. We are living at the only time when the universe can truly be studied in its full richness. And that brings us back to the original question: what is beyond the edge of the universe? After everything we have learned, the answer becomes less about a place and more about a limitation. The edge is not a wall. It is not a boundary in space. It is the limit of information. It is the furthest distance that light has had time to travel. Beyond it, there may be more universe, possibly infinitely more. But it is forever hidden from us, not by distance alone, but by the structure of reality itself. And perhaps that is the most important realization of all. The universe does not present itself as something to be fully seen. It presents itself as something to be explored, not finished, not complete, always expanding, always revealing, and always just slightly beyond our reach. So when you look up at the night sky, you are not seeing the edge of existence. You are seeing the edge of what time has allowed you to witness. And beyond that edge, there is only one certainty: more universe, more time, more mystery, and more questions waiting to be asked. And somewhere, beyond everything we can ever observe, the universe is still unfolding, quietly, endlessly, indifferently, and we are here for a brief moment, trying to understand a story that may never truly end.